Okay, so now I'm going to walk us through an example of this, let's see, this coursework. Oh, here it is. Okay, so let me share my screen. That's not what I wanted it on. This is not what I wanted it on at all. Let me try that again. There we go. Okay, so here's my example. So you can find this data in day 21 content. It's called baby weight. So we're looking at adolescent females, and we think that they're much more likely to deliver low birth weight babies than adult females. And we want to show this with some data that we collected. So you can see here the data we have is mother's age and baby weight, and this is in grams. Okay, so don't be alarmed, it's not pounds. Okay, so the first thing we want to do is get to know the data, and the very first thing we do, even if it doesn't ask us, I need to identify my response variable and my predictor variable. I need to be able to say which is which, okay? So I'm just gonna look through the questions real quick with you, and then we're gonna go right into the Minitab screen so I don't have to keep going back and forth. So we're gonna identify my Y and my X. I'm going to use Minitab to get a scatter plot and to get my correlation value. And I'm going to write some interpretations here and do this regression analysis. Regression analysis just means I'm going to build my model. So let me switch my screen over to my Minitab so we can work on this together. Okay, so here's my Minitab. So hopefully you have this as well already downloaded. So the first thing I do when I'm looking at this, I'm going to change my name of my columns so it says X and Y, or you can write response and predictor, whatever you want to do, because then that way it's just easy to plug them in to everything we're going to plug it into, because we're going to go to multiple screens and multiple locations here. So I have to think about what is explaining what is predicting what. So you can test it out if you don't already know. Do I think baby weight can explain mother's age, or do I think a mother's age can explain the baby's weight? You can even just read the problem. The way we want to go with this is that mother's age can explain baby's weight. So baby weight is my response variable. This is my Y. So I'm just going to double click in here, and I'm going to change this name, just put in parentheses Y. Then that way I know that is my response variable. You can even put Y and then put response. Maybe I'll do that. RSP for response variable. And maybe next to mother's age, I'm going to put X. Okay, then that way when I go in, I don't have to keep second guessing and thinking about it. It's just done. I've thought about it and I've labeled it. Okay, so the next thing after this question is I want to figure out how to make this scatter plot. So I want to get this visual. Now there's a couple different ways, and we're going to see a couple different things going on, but I'm going to show you just the generic way first, and then when we do something else, you're going to see a scatter plot pops up as well. So just the regular generic way is just going to graph, and scatter plot is the very first option, which is nice and easy. I'm going to click on that. And when that pops up, it's going to ask me what type I have. I just want to look at simple. Later on, we might look at it with regression, which means the line of best fit. But right now, I just want to get an idea of what's going on. So I'm going to say simple. Click OK. Right here, my Y variables and X variables. So right in line 1, I'm going to enter my Y variable just by double clicking on baby weight. My X variable, double click on mother's age. I don't have to change anything here, but of course, if you want, you can play around with some different options, but I don't really need to do anything. So I'm just going to click OK. And so I can get my scatter plot. So we're going to see the scatter plot, hopefully, in a second. When I'm doing these lectures, it seems to slow down my Minitab on my computer. But we will see the scatter plot, and we can look at the relationship, and we can comment on the relationship, which is part of the question here. If I can find that. Okay, so here is my scatter plot. So we can see that there's 1 point for each XY pair. Now I can clearly see that I have a positive slope, meaning that as X increases, Y also increases. That gives me a positive slope. So I would say from here, without knowing my correlation value, just getting an idea, it looks like there's a positive linear relationship, and I would say it's moderate. So maybe I would say that there's a moderate positive linear relationship between mother's age and baby's weight. Okay, that's kind of statement I would use for that. Okay, and then the next thing I want to do here is I want to calculate R. So now when I calculate R, what that does is that's actually going to give me a value instead of just a visual to kind of describe what's going on. And what I like about the R calculation is it gives me a strength, right? So it's not a guessing game if it's moderate or strong or weak. So it gives me more. So for this, I'm going to go into stat, and right under basic statistics, that's almost down to the bottom, it's like the fifth from the bottom, it will say correlation here. Now I believe this is the only thing other than the graph that I go under basic statistics for the regression. Everything else will be under regression. But getting my R value is not under regression, it's under basic statistics. So I'm going to click on correlation, that's R. And I'm going to enter in my, my 2 variables here. Now what I want you to keep in mind, if you enter your X variable in first, and then your Y variable second, you're going to get a scatter plot in this output that looks identical to the other one we just got. So you could always just do this, and you kind of get 2 things at once. You don't have to do it that way. I just like you to know that it's there, right? If you want to do it that way. If you want to put Y in first and then X, you're going to have a little bit of a transposed scatter plot. It's not a real scatter plot of what we're looking at for the XY. But just so you know, so put X in first and then Y, and then you'll get the same scatter plot that we just got. I don't have to click anything special in here. Just going to leave it as is. So I'm going to click OK so I can get this output. So there it is. You could see the scatter plot. It looks identical to the last one. Right? If you look over here, it looks identical, just a little bit smaller dots. And right here on the scatter plot, you can see R. R is equal to 0.88. That's actually pretty strong. So if I'm going to interpret R, I would say it's a strong positive linear relationship between mother's age and baby's weight. I wouldn't say moderate anymore, but it's just, you know, that's what happens when you're looking at a graph. I want you to know below the graph and below this next box, I have correlations, and right here, baby weight with mother's age, 0.884. So there's the value that you actually want to get. It's just, it's also in the graph there. Okay. All right, so that's getting my correlation value. So let me take a look here at the questions. So after I get my correlation value, it says study the scatter plot and correlation value, write a complete sentence. We just did that. We just said it, that it's a positive, you know, strong positive linear relationship between mother's age and baby weight. Now I want to use Minitab to perform the regression analysis. This means I'm going to build my model. So you know in ANOVA, we had to build the model. We had to fit the model first. That's exactly what we have to do in regression, but now for regression. Okay, so I'm going to go to stat, regression. I have to go to regression one more time. So the second one down. Now you can see everything is grayed out in this option, right? There's the top 2 that are in the black. Everything else is grayed out. That's because I have to fit my model first. So this is the thing I have to do before I can move forward with anything else. So I'm going to click on fit the model. I'm only going to use the first 2 boxes. My response variable is my Y. I'm going to bring that in, my first box. The predictor is my X, oops, right here. My second box will have my X variable, my mother's age in there. I'm never going to use this categorical predictors, okay? So that is going to stay blank We're not using that. It's going to be y first box, x second box. Now here I don't have to click anything. I can just go ahead and click OK. If you want to play around with some of these things, of course you can, but we don't need to right now for my simple linear regression. Okay, so here's my output. Look at right here, the very first thing. Here's my regression equation. Here's my y hat is equal to, here's my y-intercept, and here 245.1 is my slope times my x, my mother's age. So when I'm looking at fitting my model and doing my regression analysis, it's getting this regression equation. So if I say let's perform regression analysis here on simple linear regression, this is what I want to get, all of this output, but we're looking at the equation, okay? So on here you'll say, it says put the regression equation output here. So here it is. I would copy this part and put it there. Now I want to interpret the slope and the y-intercept. So here, let me see. Yeah, okay. So here when I have my my slope, which is 245.1, I can say that for each unit increase in mother's age, and I believe in the problem it might be years. Oops. Let me see. Because it probably says, and I can be very specific, yep, ages and years. So I could say for each year increase in mother's age, the baby weight will also increase by 245.1 grams on average. Okay, so that would be my interpretation of that. Then my y-intercept, to interpret that, it's negative 1,163. Now I need to make sure that it's okay to interpret that, meaning does x equal 0 make sense? So having a mother's age of 0, does that make sense to make a prediction for baby's weight? It does not. So I would not interpret that value. So I would just say that my y-intercept is negative 1,163, but it does not make sense to interpret. Okay. And that's exactly what I would do for that one. Okay, so now using the model summary and regression output, I want to identify the standard error here. The standard error is the next 2 boxes down, actually, right here under my model summary. It's S, my standard error, 205.308. That is my standard error. Okay, right here. Now, in the second part of this example, it says run some diagnostics. I want to get a fitted line plot, and I want to talk about R squared. Well, I'm going to show you how to get the fitted line plot, but I want you to understand R squared is right next to S. So it has my standard error, and then right next to it is my R squared, 78.09. We are not looking at R squared adjusted right now. We will, but not today. Okay, so it's not this number, it's the first one here, the second number, the first R squared. So 78.09 is my R squared. So let's go ahead and take a look at the fitted line plot. I can get this a couple different ways. You saw how under graph and scatter plot, I could put my line on there. I mentioned that when we did that. Or you can actually go ahead and get a fitted line plot, which is under stat, regression, fitted line plot. Okay, so I'm going to click on that. And the only difference here is you're going to get more information on the fitted line plot than you would just the scatter plot with the line on it. So of course, Y, I need to put in the baby weight, and X, mother's age. My type of regression model is going to be linear. That's all we're doing right now, linear. I don't need to check anything else. Just go ahead and click OK. And there it is. Here is my fitted line plot. Now what I like about this, it's my scatter plot that I already had, but now it has my line, right? Which I could have gotten before, but now look over here to the right. It has S, R squared, and then R squared adjusted, which we're not looking at the adjusted right now. So it has my S and my R squared. So now I can report those. I could have gotten that before, but it's just, there's different ways to get the same thing, multiple different ways to get the same thing. Okay, so there's my fitted line plot. Now, if I'm going back to the problem and it wants me to decide if my line fits well, is my line a good line to make predictions? Like, would you feel comfortable making predictions? This is all based on R squared. So R squared is 78. Yes, it's greater than 75%. I would feel pretty confident with my predictions using this line. Okay, so that's what I would say here. Of course, on the typed notes, you can see the like what I would write up exactly in the completed example. Now it says use the regression equation. So I actually want to use the equation to make some predictions. So the first one says to predict the baby's weight for a mother who's 18 years old. So I can easily just take my equation and plug 18 in for X and just find that, do a little algebra, or I can use Minitab. So I'm going to just take the lazy way out right now, and I'm going to use Minitab. So I'm going to go to Stat, Regression, back under Regression again, and now you will see the third option down is Predict, and that is not grayed out anymore. It's black, and the reason why that is because I fit the model. I can't predict something if I don't have my model already in Minitab. So I'm going to click on that, and I'm just going to make sure baby weight is my response. Good. Mother's age, my X. Awesome. And I'm going to just type in what I want to know, and I want to know for 18. Okay. You could type in multiple values and get multiple values out. But right now we just want to know the 18. So I'm going to click OK, and I will get my output here. So it still gives me all this stuff, but what I want you to know and I want you to recognize, I'm looking under prediction because that's what I'm doing, and it's the fit. So the very first piece of output here under prediction, fit. So it's 3,249.25 grams is the predicted weight of a baby from a mother that's 18 years old based on our model. Okay, so now the next question, it says to predict using our model a mother that's 38 years old. And my response to this is I cannot do that. This problem in the data is for adolescent mothers, not adult mothers. Okay, 38 is not adolescent. So your response here, and you would just say that a 38-year-old mother is out of the scope of range of what our data is for, and you cannot make a prediction for that. Okay, so make sure when you're making predictions, they're in the scope for what we're actually studying, and it's not something off, right? So that's how I would respond to that. Okay. And I think that was all the questions on that first example. So this was just a review from chapter 4, from stat 1. I just want you to know that this stuff we all did in stat 1. It's just we used our calculators or we did some stuff by hand. We didn't have Minitab, but really everything is the same thing. We didn't really look at standard error. That was kind of a new thing. And we did look at fitted line plots. Some of us did, but not always. Sometimes it was just a scatter plot. So there's a couple new things, but just so you know, it was just a review from stat 1, and that's all we're going to do for today. So I hope you enjoyed this, and good luck on your daily. Of course, I will be in our class for our second hour. For any questions, feel free to join me and let me know. All right. Have a good day, everyone. Bye.